Hey everybody, Troy here. Welcome to another FAQ video with us here at Cemanco. Today we're going to be talking about our KMK linear traverse, which is this guy right here. This is our 20mm model. And we're going to handle two questions today because the first one's really simple. The first one is, what's the difference between left and right rotation? Well, if you imagine the shaft here, if you're looking at the top of the shaft, left rotation, the top of the shaft will be rotating away from you. And right rotation, the top of the shaft will be rotating towards you. The difference will be the location of the reversal lever. For right rotation, the reversal lever will be under the dial. For left rotation, the reversal lever will be under the guide rollers in the back. The reason for this is clearance. The stop bridges that actuate this little lever here stick out about so far. And depending on where you have this installed, let's say a buncher for instance, you may need to flip this lever around to the back so that you have clearance for your stop bridges. The second question is, can I make this thing move faster or slower than the options I have within a dial here? The answer is yes. Here's where things get a little complicated.
Now it's only a little complicated, and I'm going to make it real easy for you, so no worries. What you're going to want to do is go to our website, www.cemanco.com. Link will be in the description as always. Then choose Spooling Traverse from the menu at the top, all from the drop-down menu, and Spooling Traverse LW15, LW20, LW30 is the page you want. When you're on that page, scroll down slightly until you come to the very first table. We'll continue to use the LW20 as our example, so that's the column we want, and the row we want is the one labeled max pitch. Under the LW20, this is 15 millimeters. What this means, at the maximum pitch setting of 10, for every one rotation of the shaft, the box will travel 15 millimeters. Now, if your material doesn't get any bigger than 15 millimeters in diameter, that's fine. But if it is bigger, what you're going to need to do is increase the ratio of shaft rotations over the ratio of spool rotations. So let's use a ratio of 2:1 shaft to spool as an example. For every 2 rotations the shaft makes, the spool will make 1 rotation. This will double the distance that the box travels across the width of the spool from 15 millimeters to 30 millimeters. If you want to go the other way and get the box to travel less distance across the width of the spool, you'll need to make a ratio of 2:1 spool to shaft. For every 2 times the spool rotates, the shaft rotates once. This will cut the distance in half from 15 millimeters to 7.5 millimeters.
Now I just stuck with the upper end of the table there to keep things simple to understand. Where you would want to have the ratio of 2:1 spool to shaft is down here at the bottom setting of 1. The minimum distance this will travel is 1.5 millimeters. So if you want to go lower than that, that's where you would have the spool to shaft ratio of 2:1. So that does it for this video. I hope you found it helpful. As always, I hope you leave a like. I hope you'll subscribe, hit that notification bell, and if you have anything you'd like to add or any other questions, please feel free to leave some comments. Our goal for that is to take the comments, answer them, and collect all of this information so we can have a nice little FAQ resource center that we're going to add to our website in the future. Links will be in the description for everything that I mentioned today, and I'll see you next time.